Anyway, we'll just do a small presentation, a small video of overall system. What you see out here is just a collector, which basically this part. But it's part of the overall thing that basically you have collectors, and you have boilers, and heat pumps, and it's like all integrated system that runs all together, right? So basically we're going to explain component by component what it's how it's going to. It's basically just the whole thing, but if we had the wireless connection or internet connection, we could actually show the commercial project that's working right now and showing actual temperatures, recovering rate, and so on and so forth. So a big hotel running the systems right now.
Where is it?
Both.
Where?
It's in Carpathian Mountains,
okay.
basically. So it's about 150 rooms or something like that hotel. Anyway, so that's the one that we call...
Carpathian, that's in Hungary or Romania?
Ukraine.
Yeah.
Ah, Ukraine.
Ukraine, okay.
Yeah, Ukraine. So in Mountains. Anyway, so it's a small one they installed that in Finland.
The top cover, is it glass or is it
Yes.
like some other? Okay.
No, it's a glass. It's basically, this is the one that you see is there on the stand right now, right? So that you would just bring it over, mount it on top, and then I guess connect them online.
What's the temperature level of the water you're trying to reach? Is that, or the maximum temperature you've measured so far?
The maximum
Is it for water heating or space heating?
space heating.
Space heating.
Yeah, because it's
Space heating and cooling. So basically we have two type of plugins. So this one is also solar stellator, or air, we call it helio air heat exchanger.
yeah. So as you can see, it's not only collects from the sun, but also you get exhaust warm air coming from the house, right? So you send it through the collector itself. That's what we talked about, the air part of it.
So is the water
Is the water used as a storage, and then you heat air from the water?
No, well, basically, yes. If you have a space heating, for example, in European houses, quite often it's space heating, right? So it's radiant heating.
Radiant heat, okay.
So you plug into that much easier. Out here we have forced air, which is not as efficient and not as big. But
Okay.
Just for me as a question, what's the temperature you have of the exhaust air? Don't you put if you have a high inlet temperature of the collector, wouldn't the efficiency drop? Rather, wouldn't it be better to have a heat exchanger which is coming later? Because as long as the lift of the temperature, if you have the colder your inlet temperature, the bigger your...
no, I understand what you're saying, yeah, no, but it's actually, it works quite well the way it is right now. That's why it was before we had the system that wasn't collecting any air at all.
Okay.
But we just put it on top, and it seems to be getting...
So you're collecting, you are getting the heated air from the back, basically?
Front.
What? From the front?
Yes, in front. Yeah.
From the front, yeah.
The company manufactures heat exchangers. That's our sort of base.
Yes, basically, see, the heat exchanger, the basic one, you can see it's going in the heat
steel
tank.
heat exchangers. We can
Right.
cover it with a selective paint. That's where we get our absorbers that we can use. We build our own solar boilers, or
Yeah, so this is a solar boiler, right, that if we go in, that's where the storage goes in. And we use the same type of collector that goes in, but it's uncoated, that goes inside of the boiler, right? And the coated one, the one you see inside of that, we actually have those separate ones. We have samples right in there. Smaller ones
Yes,
and
we have
longer
some
ones
of
by
them.
itself. Yeah, they're pretty sharp. You have to watch it because it's used from stainless steel, like really thin, so it's like really, we got quite a few cuts just handling it, so you have to be really careful. So. Anyway, so that's a boiler. That's what we have, like about 4 planes you go inside, right? So, for a full length of it, it's usually where it goes in there. And then, of course, there's a big thermal accumulator, right? So that's wow.
Storage.
It's a storage, quite huge. In see it, we kind of
So you use fiberglass.
yeah.
polypropylene.
How many liters is that one?
6,000. It's a
6,000.
polypropylene.
Polypropylene.
How deep underground you put it?
It actually could be on top of the ground.
Yeah.
I guess some Finnish military put this and kind of made it like a big pig or something like that. So it looks like. put some ears in it, you know, some kind of.
It's the same sort of
Yeah.
heat exchanger.
Yeah, exactly. It
Same
goes in there as
plates
well
or-
because it's.
Also, we have to bend it to be able to go inside of it.
That's for
Right, so just
insulating.
insulating it a little bit further, and I mean, obviously, if you put it in ground, that makes it a little bit more efficient.
To what temperature you can load the storage?
You mean what the temperature goes inside?
No, to what's the maximum temperature you could
The
put?
maximum, 100.
Have to
Anyway,
double check.
Is it,
We'll-
is,
we'll
it
get-
is that pressurized or is it pressureless?
I don't think it can be pressurized with that thing.
no, no, it's
It
not.
doesn't look pressurized, huh? It's not
No.
pressurized.
So see, that's why we're going. It can be right
That
next to
was
the house.
The reference project was done back in February. It's a small town of
So,
Jones.
it's mainly designed to go into the ground, yeah.
But
This
like I said,
particular-
you can put
yes,
above
but
the
you can
ground.
put,
To save space.
Well, six space more aesthetically pleasing.
For this
you know.
particular customer, he wanted to put the next to his building because he didn't have space in a crawling space in the
Okay.
basement or something.
That's what it is, but it's not. Yeah.
It's cost him a little bit more.
So indoor is probably more efficient.
It's indoors more, exactly.
But it's
Yeah.
big volume.
Yeah, and it's just access
Take
to
half
it
of the
from
room.
the top. Yeah, so the way so you can get to it. Again, if you want to service it, you won't be able to pull the collectors itself.
It's a sort of
Same
small
ones that-
single house type of system that you see here. We do commercial also as well. Yeah, residential is small. And
And they're like just suspended, and so they're just floating, and multiple of them inside of the tank. So anyways, that was this particular.
What's the efficiency of this heat
pump?
pump here?
I don't
COP.
here. I don't have, don't remember off the top of my hand, but in there, so it's integrated.
Oh, it's with numbers. 2 points.
4.9, you said that?
You have a source, it's using deep water.
Okay, so.
R410.
What's the delta T again for the heat pump?
Sorry?
What's the delta T?
3.8 is that?
3.8 current max. Yeah.
No, that's amps, that's water voltage.
It's up top right.
Hold on.
It's COP of heat,
Yeah, 4.0.
and that's
Coal fire,
under efficient
yeah.
something that's also some of the numbers
6
for consumer
kilowatts and 2.7.
consumer product.
Water flow 0.15.
Yeah, I think
Doesn't give it.
this is about maximum.
So, just a moment, so you are using this for ground, not using, not connected to the solar collector?
No, well, it's a whole system, right? There's
Connects
multiple-
so
it
hot
connects to
water,
water.
hot water, right?
It connects from the
Solar?
Well, basically at the bottom, you'll see it. It's connected there. It pumps the heat. There, see, that's what it is. It goes in. So collector itself, it's on top on the roof, right? And that's where we saw the big one got in, and that's where the heat pump goes, right? And that's the main controller of it. That's where it controls where the water goes to. So whether you send it to heat storage, or you send it to this, or you, anyway, so that's pretty complicated.
So if the temperature is high, it goes directly to the storage. If it's
Exactly.
low, it
Controls.
will go to the heat pump.
Exactly,
Yeah.
exactly. Anyway, so you'll see it, it's pretty, there's quite a few valves.
So
to go into
typically, if
control it.
it's 50 degrees and higher, it will go to the storage. It will
Exactly.
hit the
So we have
storage
a program-
directly.
Exactly, so we have a program
Yeah.
that controls this pump, how it's, which valves
Yeah.
open, which close.
Yeah.
Right. So anyway, so that was the
50 degrees
overall list.
south.
Yeah, but it
No, so it's-
breaks.
Gee, what time do you have the other room?
12 o'clock.
Okay. So,
Let me get a room number. It's -4.
Okay, is the test ready now?
Glycol for
It's testing.
freezing
It's testing now?
protection?
It's
And
still
solid
testing. I
collector
would
you
say to just have some,
Yeah,
something.
well, if
Oh,
you run
okay,
it,
well,
it's
put
gonna-
yours now.
Again, you can use it,
Okay.
Okay,
Put yours.
tap water,
Okay.
but have to go through the filtration